For today's lesson, our focus standard comes from Grade 7, Statistics and Probability, Standard 2. Generate multiple samples to gauge the variation in estimates or predictions. Our topic for this lesson comes from Data and Statistics, Sample Variability. Our essential question is, what effect does the ratio of the sample size to the population have on the variability of the sample data? Please take a moment pausing the video if you need to copy down the topic and essential question into your header along with today's date, save your question column and your note column, and resume the video when you're ready to begin. In our study of samples and populations within this data and statistics unit, we have learned that it's important that samples are random, representative, and proportional. Today we're going to focus in on what it means for the sample to be proportional and how the reliability of our statistical analysis of the sample data depends on these factors. So we've already done some work with why random is important and representative, and we've begun to work with proportional. So let's think about that for just a minute. If this orange box represents the population data and this blue circle represents the sample, right now this is a pretty small sample of a large population. So it is a small proportion of the entire population. What do you think the effect is if I were to take a larger sample and do some statistical analysis? So if I was to increase it so that the sample size represented a larger proportion of the entire population, what effect do you think that'll have on how the data we do through our analysis varies? Well, that's exactly the question that we're looking into today. So let's go ahead and look at the data set we're going to use to explore this concept. I've recently moved into a new neighborhood further out in the Portland area and have been surprised at the number of vehicles per household. So what I've gone here is to 50 houses in my neighborhood and counted up the number of vehicles per household. And so first house I went to had 1 car, next house had 3 cars, 5, 8, so on and so forth. So this represents the 50 houses in my neighborhood and the number of vehicles per household. So here's, I started out with taking some samples, some random samples of this data. So let's go ahead and see what I've done here. I went ahead to took 4 randomly selected homes from this data set and calculated the mean. And then I did it again. I did it a second time. So here are the first samples that I took. It was 4, so the first in my sample was, and I added that up to find a total of 24. What do you think my second step was to find the mean? I added up the numbers in my sample, the 4 numbers in my sample, got the total. What do you think is the second step? Yeah, that's right. I took the total, which was 24, and divided it by 4, because there's 4 data points in my sample. And what I came up with for the mean number of vehicles in my first sample was 6. So as I said, I've repeated this process with another random sample of 4 selected homes. I've added up the total here. And you're right, I haven't finished that calculation, so let's go ahead, pause the video if you need to, and finish that calculation. In doing so, I got 8. 8 was the mean number of vehicles from this second sample. So right away, what do you notice about the statistical analysis so far? Well, a couple things that come to mind. I did 4 randomly selected homes, so I actually have, if we're using this circle here, a really small proportion. My sample is only 4 homes out of 50. So that's one thing I'm noticing. And look at the mean numbers. My first mean was 6, and my second mean of my second sample of 4 randomly selected homes was 8. Now, considering the lowest data point is 0 and the highest data point is 9, this is a pretty big spread of two numbers. So this was curious to me. So what I did is go ahead and do this a few more times until I had 10 samples of 4 randomly selected homes, and I calculated the mean of those. Let's go ahead and see what happened. So like I said, here's my one with 6, here's my one with 8. And I did this 8 more times where I took a random sample of 4 and calculated the mean, and I made a dot plot here of what I got. So the mean, I did this, I took all these and I added up and took the mean. It's about 6.2. And you can kind of see that from our data plots, if I were to informally try and find what the mean is, it would be about here. I could agree with that. And the data, the mean calculations have a range of 6. So it starts down here at 3 and stretches up 6 places to 9. So there's a lot of spread. This is the kind of variability that we're talking about. So I took a small sample, I repeated the calculations 10 times, and I'm getting a wide variety of calculations for what the mean number of vehicles are in per household in my neighborhood. So to explore this idea of how does the proportion of the sample to the population affect the data that I get, I went ahead and repeated this process, but this time I enlarged my sample size. So I increased my sample size. What do you think, what kind of effect do you think that'll have? Here I had a difference of 2 in my calculations of the mean, and I had a wide range of data. What do you think will happen if I increase the sample size from 4? Well, let's take a look. Instead of using 4 randomly selected homes, I started over and I did 15 randomly selected homes from the same data set up here. So here are the numbers that represent the randomly generated 15 homes and how many vehicles they had for my first sample. And I added it all up to get a total of 64. Since I had 15 data points here, I took 64 and divided it by 15 and came up with the mean number of vehicles being 4.2. So I repeated that with a second sample of 15 randomly selected homes. Here are those 15 data points from that data set above. I added them all up together, got a total of 70. Once again, took that total, since we're calculating the mean or the average, and divided that by 15 for an average of 4.6 as the average number of vehicles per home in my neighborhood. So just looking at these two samples, what do you notice is different from when I've done it with 15 randomly selected homes compared when I did this with only 4 randomly selected homes? Well, if you said they're much closer, I would agree with you. Here I'm getting 4.2, here I'm getting 4.6. That's extremely close. We're only off by 400ths, whereas up here we were off by 2. And again, it's not that anyone did any calculations that were wrong. The only difference is our sample size has increased. So once again, to just see what would happen if I did this for a total of 10 times, I went ahead and did that and made a dot plot of my data. So here they are. So I had a couple that were 4. I put this one in as 4, I put this one in as 5. So there are my data points. I repeated it 8 more times. And look at the difference in the dot plot. And right away we see it's a much smaller range. It's narrowing in here, just like our difference here narrowed in. And when I calculated the mean of all of these, so I added these all up and calculated the mean, I got 4.7. And once again, if you just kind of look at this data in this dot plot, you can see that, yeah, the mean would be right in here, just informally trying to figure out where that middle or where that average is. So by increasing the sample size, we have decreased the range or the spread of the data, and our calculation of the mean is getting much closer every time that we do it. And so what do you think is important then on the proportion? The larger the sample size, the smaller the variability, and therefore it makes for more reliable data analysis that we can use for predictions about the population.